Oops. Nuclear cooling towers. We'll talk about those in a minute.
No. So it's like a waste.
Yeah, there we go. So, worksheet 2 on ellipses. What questions do you have? Oh, we got some early candidates here.
Number 6.
6. Olivia, which one were you going to say? 6 and 7. Jason, did you have an option there?
Yeah, number 9.
6, 7, and 9.
I put stuff in the wrong folders.
4, 8.
4, 8. He's left out.
8.
Reminds me of the why is 6 afraid of 7? Anyway, number 6.
7, 8, 9.
Which of the following is true? An ellipse with foci at -5, 4 and -1, 4 must have a center at -3, 4. This, to me, I have to draw a picture of this. I can't do this problem without drawing a picture. At least the first one, anyway. So -5, 4, -1, 4. Wait, let's draw a better picture than that. So there's -5, 4. There's -1, 4. This is number 6. Which of the following is true? An ellipse with foci at -5, 4, -1, 4 must have a center at -3, 4. Okay, well, the center is always the center of the ellipse. It's right in between the foci. So that foci would have to be right there. So its y value would have to be 4.
Could be.
And its x value would have to be -3. So yes, 1 is true. The center's got to be right in between the foci. And maybe you can figure that out without drawing the picture, but I think the picture is helpful. An ellipse with foci at -7, 8 and -7, -4. -7, 8, -7, -4. Those are the two foci. So the center would have to be right there in the middle.
Yeah.
And let's see, 2 is right in between. Yeah, 2's in between. So, and this x value is -7. So, yep, we're good on that one.
Bingo.
An ellipse with foci at, this one's going to be a little tricky maybe, 5 plus or minus square root of 17, -2. So plus or minus square root of 17. Must have a center at -5, -2. What? Foci, center? I don't think so. I don't think so.
If it was a -5.
If it had been a +5, or this one was a -5, then yes. But right now, that's a no.
That don't work.
That doesn't look. That's definitely not right.
C.
So yes, answer choice C. 1 and 2 are true. Number 7. 7 was a tricky one because you don't really want to find the equation for all of those. Like, that would be annoying. It's one way to do it. But let's think about when we do the equation. Let's look at B. So we'd have 6 times something plus 6 times something equals some number over there, right? Like, I don't want to do this whole problem. I want to cruise through and see if I can figure out what's going on. So you're okay with? Are you okay with me doing this? Like, that's what it would look like. I'm passing on the details right now, but it would look like that. And then whatever number is over here, we would divide by, let's just say it's A, to make it equal to 1. Well, if this one is 6 over A, this one's 6 over A, they're going to end up with the same denominator. Whatever the denominator is, I don't know, but those two denominators are going to equal each other.
Oh, it is.
Right? Whatever they are, I don't know what they are, but they're going to be the same.
And if one's not positive, one's not.
And if they're the same, whichever one's under X is like the left and right radius, and whichever one under Y is the up and down radius. But if they're the same, what shape is that going to make?
A circle.
A circle. So this one's a circle.
So if they're the same,
So if the x squared and y squared coordinates or coefficients are the same, that video mentioned that a circle is a special case of an ellipse. This would be the example of that. So that one's a circle. The others, these are different, so they're going to end up with different.
So would that be a correct answer or incorrect answer?
So which of the following is not an ellipse? B is not an ellipse because it's a circle. Because
even though you said
it's not, well, if you're going to argue that it's a special case of an ellipse, then I would entertain that argument. You could say none of them because it's like squares and rectangles. But we don't usually make that distinction with ellipses and circles.
So for the test, if it has something like that, it would be not a circle. I'm not an ellipse.
Yeah,
Just
we're going to
based
say
on
circles and
distance.
ellipses are separate things. It's not like
In real life, they are, but not
rectangles
this.
and squares.
Okay.
Number 9. Which of the following equations is the equation of an ellipse with center negative 3, 4? So, let's see. How much algebra can I skip at once? A lot, huh? So, group the x's, group the y's, and then b over 2 would be negative 3. b over 2 would be 4. So I'm just trying to get to the center, so I don't really want to do the whole problem. So that would be x minus 3 squared. And that would be y plus 4 squared. Right? So that one does not have a center at negative 3, 4.
Wait, so if you just look for the ones.
So, I mean, I feel like you got to do some work.
I think it's 2.
X squared
It's double
plus
it, and then
6x.
one of them switched with a positive and
it's
negative.
well
That's yours.
split the answer choices.
Oh, it can't be 1. So
Yeah.
that's out, that's out, that's out, and that's out.
It's rule.
There you go.
Bingo.
That's how you should work those problems. Why work 3 problems when working 1 problem gets you the answer? I'm going to go ahead and finish number 2 to verify, and then I'll feel good about my answer. You guys feel good about your answer already.
You could have made a mistake. I believe it.
So b over 2 is 3.
I've seen it.
b over 2 is negative 4. And I guess that's what's misleading, is like that looks like negative 3, 4, but when you put it in...
I mean, if you also look at it, it's double the other one, and it just switches the values into negatives in some form.
So 2 is right,
So it has to switch the
so it's b.
You could choose.
So you get the feel on some of these problems. You don't have to work the full thing. Like, work enough so you can see what you're trying to answer, but you don't have to do the whole thing. That was definitely true on 7 and 9. All right, anything else from that worksheet?
Jason, just choose a random number. Jason's bad, Jason. Why not 10?
Because I said no, 8.
8. Sure, we'll do both.
8. Which of the following is equivalent to that thing? So basically put that thing in the right format and see what happens. So that's a good one to do because we kind of short-circuited everything on the last one. So we'll do this one for real. And again, we've done enough of these that we can skip a few steps along the way. Like we've grouped the x's and factored out in one step. Half it, square it, add it now. So plus 1, but what did I really just do?
You added 1 on the right.
I had 1 on the left, but what did I really add to the left-hand side of the equation? I wrote plus 1, but what did I add? 4, because of the 4 out front. And then for the second piece, b over 2 is again 1.
That's 3.
Square it, we get 1, but the 3 out front means plus 3. So that's 24. So 4 times x plus 1 squared plus 3 times y plus 1 squared. Start looking at my answer choices. Oh, but they all have x plus 1 and y plus 1, so not helpful yet. Divide everybody by 24. So the x stuff becomes 4 over 6. The y stuff becomes, not 4 over 6, 1 over 6. 3 over 24 becomes 1 over 8. So it's answer choice C. I don't know if it's easy, but easy when Mr. Wolf does it, right?
Mhm.